Okay, so hi all. In this video, we will mostly be doing some coding to get our hash tables off the ground. We'll mostly be getting our first program together. We'll write the basic functions to getting a hash table built up, printed out, and to do search, which is sort of the three main or simplest operations. In the programming assignment that you're going to hopefully start working on this weekend, you are going to take some of these that we're doing together and add to it, right? Add some other functionalities. You're going to add a couple of alternate, I guess I'll say, searching things, modify the node a little bit to have it be a little more interesting than just numbers, which is what the example that we're doing. And most importantly, you're going to add the delete, the ability to remove from a hash table, which we're not going to code here, but is, you've done remove or deletes in some of our other programs, and it's similar at the very least. So, but anyway, we'll talk a little bit about that at the end of this video. So, but before that, what's our goal here, right, is to say, so I think we've talked about a hash table enough. I don't know, maybe I'll leave this one on the screen here just for a brief second. So the idea of a hash table, of course, should be that we are organizing the data nodes, which are the blue boxes here. We are organizing them according to some value, known as the key value. In this example, and in the one we're about to code, we're just going to have numbers that we're storing. So those are also the key values. But you're going to be working on a program where you're storing name and ID number. So of course the ID number is what we use as the key value. And we're going to use a hash function, a hash table, and a hash function to decide where these values should be located. So rather than us just saying, oh, let's just start at the beginning and start filling them in until we run out of space, which is mostly how we've done, filling stuff in, or we always put it, we prepend or we append or something like that. Okay, but there's no science to that, or there's no logic involved in where should things go. It's mostly just sort of, well, where do you have space, right? Or where's an easy place to put this? Well, hashing is much more clever, because it says, well, rather than just putting these nodes in random, or basically random places, I'm going to organize them according to some rule. And that rule, of course, is the hash function. And for us, since this is not a course entirely dedicated to security and networking, we're just going to use a simple hash function like a mod. So if we mod by, the common thing to do is however big your array is, in this case 7, just mod by that, because of course then you end up with a remainder of 0 through 6, which is perfect, because that'll tell us, row 4, for example, those are the things that have a remainder of 4 when you're dividing by 7. Okay, so in this numerical example, it was pretty easy to figure out where they should go. And then the ideas, of course, our table, our hash table itself, is actually, so it's a little misleading that there's these blue boxes here. These aren't actual nodes. These are just pointers. So actually, in many ways, this would be a better picture without these blue boxes here. And just to say, so slot 0 of the array is this arrow. Remember, the array itself is not holding any memory or any nodes. The array instead is holding first pointers, as we might call these black arrows right here. These are the first pointers leading to linked lists, right? One for each row. So the array itself is holding these guys, these black pointers, these firsts. And then, of course, the idea is that why do I need a linked list here is because, as we talked about last time, when you have a collision, namely two things that are trying to go into the same row, or two or more things that are trying to go in the same row, well, the idea is, of course, to say, well, if you have more than one thing trying to go in a certain row, back up a second here. So row 3, for example, so when I try to insert 24, I say, okay, that should go in row 3. So, okay, all right, row 3. So I say, all right, I'll put it in row 3. But there's already something in row 3, namely 31. But chaining takes the strategy behind chaining says, that's no big deal. This is a linked list. So why don't we use the flexibility of a linked list to say, let's move that guy over, and create a new node and put our new number, 24, in that at the head of the list, right? Or this is of course prepend, as we've been calling it for the last couple weeks. Add to the beginning of the list, or add before first. And now, of course, this is nice because I say, oh, all right, I have space for as many as I need. Let's say I have a third and a fourth and a fifth number that are going to go in row 3. No big deal. I'm just going to keep adding them at the front of each of those the linked lists are just simply going to grow, which we'll talk a little bit in the next video about. Ooh, but does that actually end up being a bad thing? Well, for now it's a good thing though, because I can have as much space as I need, and it makes finding stuff easier. If I want to find 9, for example, I don't need to start at the top of the list. I don't know why I'm pointing to the screen with my finger. Sorry, I don't need to start at the top of the list. I can say, well, 9, when I hash 9, I get 2. So all I need to do is look in row 2, and I'll ask myself, oh, okay, so is this the one I want? No. Okay, well, go to the next one. Is this the one I want? Well, in this case, yeah, it is. So in 2 quick queries, I'm able to find the number. And of course, if I was looking for a number that wasn't there, as soon as I get to the end of the list, which let's say I was looking for 16, which would also be in row 2 if it existed, as soon as I get to the end, I say, well, I looked for 16 and I got to a null, and that means it must not be in there. Oh, well, that's also a pretty quick answer to the question, no, it's not here. All right, so basically what I just reminded you of from the last video is what we're going to set out to code now. So, of course, right, so this is our structure, or this is our table. So takes, again, you have to look at this a few times before it really sinks in, but so however many rows you want, that size, and then I'm going to make an array. Obviously, this is an array because I have brackets. I'll call it table just because it's a hash table. And it's a table of what? Oh, it's a table, or it's an array of what? Oh, it's an array of pointers to nodes. So not nodes. So the table itself does not actually hold any of the data. However, what does table hold? Table's an array, and each slot of the array is a pointer to a node. And in fact, it's actually what we've been calling all along. It's the first pointer in each of these developing lists. All right, so just sort of keep that picture in mind. Maybe, we're obviously going to write this line in our code in a minute. The hash function is just a regular function, so let me not repeat that. So what are we going to try to code now? So we talked about this last video. So of course, how do I get started? Well, I simply want to declare this, declare this table using the line here. But then I want to say, all right, now if I'm going to build this up, I'm simply going to do a prepend. And since we've written that prepend code many times, I didn't write out the code here, but certainly pseudocode-wise, I'm going to basically do these 3 steps. Okay, so that seems all right. I think this is what we finished with in the last video, which was printing. Now this became a little more complicated because I forced us to do it recursively, but I think, right, even if we didn't do it recursively, there is still a little bit of a challenge to thinking about how do I print a table? Well, you got to be able to print rows and columns, right? I mean, printing a linked list is easy. You start at the beginning and you go to the end, and that's it. But of course, printing-wise, that's just one, in this case, row. So it'd be no problem to print 10 and 15, or was that a 5? 10 and 5 and then null. Oh, that's easy. But how do I say when I get here, go to the next one, and how do I say when I get to the end of that one, go to the next one, and so on? Oh, that requires a little bit of thinking. And whether you use recursion or not, you have to be a little more clever here, right? So, but I think we wrote a nice recursive function that's right here up on the screen, and so I'm mostly going to copy that into our little sample code today, so that we can see if it works, because we didn't have time to do that last time. All right, and so before I switch over to the editor, just one last slide that this doesn't really, I don't even really need to say much of this, but I'll say it anyway. The third thing that we're going to add to our program today is the ability to search. So we're going to do the adding, right, or prepending. We're going to do the print function, and then we want to probably, since the basic or the main function of a hash table is that it's supposed to make it easier to find stuff, we'll write a little searching function that's going to say, oh, okay, what number do you want me to find? And either I'm going to find it or I'm not going to find it, and print an appropriate yes, you found it, or no, you didn't find it kind of message. All right, you could do this recursively, and I think in the program that you're going to work on this weekend, you are going to do this recursively. So I'm sort of playing a little bit of a trick on you, I guess, that we're going to do this searching thing, but we're going to do it not recursively. So then I'm going to ask you to do it recursively in the program. The printing function, which we did in the last video, we did recursively here, but I'm actually going to, I think the one that I put in the program is not recursive. So I'm just trying to sort of keep us, not necessarily keep you on your toes in a mean way, but just to sort of show you kind of both ways of doing it, recursive or not recursive. All right? So let's get to it, right? So we've done enough talking. And we'll pick up with coding. So we're ready to code. All right? So we'll pick up with this. I have more notes, which we'll do next week, really just sort of on a little bit more on the design piece, but that's not crucial to you doing the program. So let me switch over to the editor here. Okay, so I have a little bit of stuff in here just out of for the sake of time here, but I'm just going to walk you through what's already in here. Nothing too significant though. Of course, we're making an array to hold this, and I think we are used to this, even though it's been a little while since we did arrays, but it's customary to have an integer called size that's going to obviously hold the size of the array, and since it will say it's a constant so that we're not tempted to change it later or something like that. All right, so I'll do 10 in this program. I forget what the size is in the one that you're working on, but it doesn't matter, right? Whatever the size is, I'll have a variable for that. So that's 10. Our usual friend is here, the node struct. That's unchanged. We're just doing single linked list, so I don't have a next and a prev. You could, if you wanted to, do a next and a prev. In fact, I'll say that when you go to code to do the program for next week, if you do want to come in here and change this to a double linked list, so in other words, make it have a next and a prev pointer, because you are going to have to do delete or remove, which, as we know, is actually easier with a double linked list. You're welcome to come back through this, or the version that you're going to start or use as your starting point. You're welcome to make it a double linked list if you want. Okay, but we'll stick with single. We're just getting our feet wet at this point. What else do I have? So I just have a hashing function here. This is not exciting at all. This just takes the value that I'm going to try to hash, and then it returns that number mod, in this case size, which is 10. So of course this is actually just going to, when you mod by 10, you actually just get the ones digit. So 67 mod 10 is just 7, right? So in essence, this is just going to strip away all of the other digits and just give you the ones digit. That's fine. So of course the hash function is going to let us know where should this go in the table, which row or which slot should it go in. Okay, so our task is to fill in three things. Our print function, which we already did, so I'll reproduce that here in a second. A search function, which we've talked a little bit about and isn't too hard, so we'll come up with some code for that. But probably it makes sense before we talk about printing or searching something to actually get some code together to build this thing. Otherwise, right, what am I printing and searching if I have nothing? So let's do the main first. Now in this program, I'm gonna, again, just to keep you on your toes a little bit here, we're gonna do it we're going to do the adding. Sorry, I don't know why I highlighted that whole thing. We're going to do the adding in our keep going kind of a loop thing. Do you want to add a number? Sure. Okay, let me put it in. Do you want to keep going? Do you have more numbers? Sure. Okay, I'll add it, and so on and so forth. Now in your program, you're going to turn this into a menu function of, do you want to add to the list, select number 2, right? So I will say, I think I was grading one of the labs, not the recursion one that you're working on or finishing up today, but I think the one or two before. Just sort of read the assignment sheet a little carefully. Some of you forgot to convert from whatever we did in class. You have to do a little bit of modifying, so just sort of bear in mind, we're doing it this way just because it's easier to get it off the ground, but you do have to do a little bit of adapting when you get to the program. But mostly just cutting and pasting this code just elsewhere. So, okay, so let's get this going. So, I'm sorry, I skipped over the stuff that was at the top here. So this is me declaring the table, And remember, of course, right, this is the variable name is table. It has 10, size is 10 slots or 10 rows of pointers, node star, right, pointers. Now, this is a cute way of setting them all to null, is that if you ever have an array and you want to put the same value in every slot, you can do it this way. So you can say equals curly brackets and then whatever value. In this case, it's null because these are all pointers. All right, so I'm going to cheat here and do that. I'm going to tell you verbally right now, and also I think I wrote it on the assignment sheet, so please don't be the person that isn't actually watching these videos or is watching them in fast forward mode. You can't do this in your program because in your program you're making a class, which means this is going to be declared separately, and then you're going to have a constructor for which you probably want to set all these things to null. So in your program, you're going to have to use a for loop. So you're not going to be able to do this in the program. So please, 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 please don't send me an email. Hey, in class, we were able to just do it this way. Why can't I do it that way in the program? Well, I'm telling you right now, you can't because these are going to be decoupled. So you're going to have to just do it the old-fashioned way, which is to just write a nice simple for loop that goes from 0 to size minus 1 and just sets all of them equal to null. All right? So that's not a colossal issue, but just FYI. Okay, I'm probably going to need a temp pointer, so I figured I might as well create that. And then these guys are just some variables I'm going to use to help me control my loop and to grab answers from the user. Okay, so let's go. So here I am. So I have nothing in my array right now, right? I have nothing in my table because all of them have been set to null. So, okay. So I ask the question, enter the new number to be inserted, and they enter that into num. And now I want to insert that into the table. Aha, okay, but of course the table, remember, the table has organization. So I think as you plan your code and whatnot, just sort of remind yourself the values of, in this case, of num, of the numbers that I'm adding here, these dictate where you should be operating in the table. Whether you're adding, deleting, searching, any of those things, you have to first say, where should I be? What row do I need to be in the table? So I think one of the first things you usually might want to do is first actually compute what row should I be in? In other words, what slot of the array is this action supposed to happen in? Well, they entered a number here, 47. Well, 47 mod 10, remember we're modding by size, which is 10. 47 mod 10 is 7. So I would probably like to know that I'm operating in row 7. So I like to have a little variable just called row or slot or whatever you want to call it. And if I send this new value they just entered called num, if I send that to the hashing function, it's going to return, in this case, if num is 47, it's going to return the number 7. Because you're right, modding by 10 is just the ones digit. So it's going to store a 7 in row, which means now I can just say, oh, well, I know row is loaded up with the correct row number. So now I can start talking about that row. Oh, well, what do I want to do on that row right now? I want to insert this new number into the list that is sticking out of row, in this case, 7. Okay, so I just want to do our usual prepend steps. Some of you have a different flavor of how you like to do prepend, so feel free to do whatever you normally do. I'll give it to you this way. So right now, I want to insert this into slot row, right? Whatever row value row is holding. So what I first might say is, well, let me use temp to hold on to or to point to whatever's currently the first node in that list. Oh gosh, how do I get to that? Okay, well let's see. So the table that holds all of the first pointers are organized in the table. But I don't want all of the first pointers. I want the one that specifically is in row. Maybe I shouldn't call it row, but you know. Right, so table bracket row, that's the arrow, that's the first arrow in the appropriate row that I'm working with. So if I say temp equals table row, temp now points to the first entry in the correct row. Aha. Okay, now it's possible that that's null, and it's also possible that that's a box, a node. But in either case, fine. Temp is holding on to, right? We like to use temp to sort of hold on to something that I might need later. And of course I need to hold on to that because if I'm going to make a new node now, I got to make sure I link it up. All right, so temp, so let's use temp as we like to hold on to whatever's in the first entry spot right now, a null or a box. Now I can ask for a new node. Now who wants a new node, or who would like to get a new node? Well, I feel a little awkward that I'm not doing this with any sort of graphics here, so okay. So right, so maybe 31, right? So maybe I'm inserting into row 3, so row is equal to 3. Table bracket row is this black arrow right here. And let's pretend for a minute that there's a box there. Fine. So our first line of code made temp equal to, point to, in this case, the 31 box. Okay, so temp is pointing to the 31 box. Great. Now if I'm going to insert into this row, I know what I'd like to do is essentially this. Right, that's what I'd like to do. So let me just back up one step. So right now, temp is pointing to 31, so it's holding on to it. And even if I've got a bunch of other stuff over here, that's fine. Temp is holding on to this box. I can get back to this box. But where would I like a new box to appear? Well, right here. So who would like this new box? This guy, this arrow, would be very happy if a new box could be created right here. Then I could fill it and link it up. Remember, temp is pointing to this one. So, but again, for the millionth time, or what seems like the millionth time, who's that arrow? Well, that arrow is table slot 3 is the name of this arrow. So in our program, who wants the new box? Table bracket row. You're going to find yourself writing table row many, many times because that is, right, the first pointer in row. Right. So table row would like a new node. Okay, and table row znum is this new number. Maybe I should have called it new num or something like that. Oh well, whatever. I don't want to confuse you here. Okay, so put the new number in that newly created box. And then let's see, table rows next. So table row is that new box now. So who comes after that? Oops, sorry, my arrow's messed up there. I'll fix that in a second. Well, it was the old one, right? So whatever used to be there. So I've inserted this node here. Table row wants a new node. Okay, so I create a new node. I put the number in. Oops. And then whose table rows next? That's this black arrow. Oh, that would like to point to the old thing that used to be first. But remember, temp's holding on to this one. So I think table rows next would like to equal temp. Okay? Sorry, I messed up my arrow here. All right, so it's just prepend, right? I promise, if you look back at any of your programs where you've done a prepend, this, I think, is more or less the code you wrote. It's just that everywhere you see table row, you probably just had first. But remember, I'm just going to keep saying it. Table row is the first pointer in row. Okay, so in many ways, it is still first. It's a specific first, all right? Okay, and then maybe I can say, do you want to add more numbers? And if I do, I'll loop back to the top and just keep doing this. So I think that works. We'll test it in a minute, but I'm pretty sure that works. All right, so we'll leave that down here in the main rather than putting it up here in a function. But probably so when I'm done with this, I probably want to print, because I probably want to double check, does this actually work? So let's type in our print function. Now we did this in the last video, so I'm not going to say a whole lot, I'm just going to go. But I think when we designed this, print function, we said, okay, I'll have a temp pointer, and I'm also going to have an integer that's going to hold what row am I on. Because as we explored last time, we need to be able to detect when we get to the last row. So remember, I think we said this last time. So if you're on null, meaning you're at the end of a row, and you're on the last row, so I could say size -1, that's the last row, 9 in our example. Now this is the moment where we know I'm totally done. So just so that we can detect it, I'll put a little print here. You're finished printing. And I'll go to the next line. And that's all I want to do, right? So if I'm on the very last row of the very last, at the very end of the very last row, I just want to say you're all done. On the other hand, I think we agreed that if you're at the end of a row, but obviously it's implied here, but you're not in the last row. Now here's where I wanted to say go to the next row and keep going. Okay? So I think we said, all right, well, one thing for sure that I want to do is I want to go to the next row. Well, row plus plus, now don't fool yourself here, right? Row plus plus, all that does is add 1 to row. Now I do want to do that, but that doesn't magically make me on the next row. That's just updating row to say, hey, if you're on row 4, you're now on row 5. What does update, where we actually are pointing to, would be for me to reset temp to our favorite thing of the day, table row. Because now that's going to say point temp to the first node in that next row, because I've updated row plus plus, right? Okay. Now I suppose there's one other thing I might want to put here if I'm trying to be a little cute, which is, of course, that in my printing, remember, this is supposed to print to the screen. I don't think I wrote this in the last one. But of course, in my printing, if I'm thinking about printing horizontally and then going to the next row, surely that would mean I probably want to do something like put an end line here in order to physically actually move me down to the next row. Okay? So I think I probably want to do that. If you want to get really fancy, you can put row numbers in, like this is row 2, this is row whatever if you want, but well, this is good enough for us now, I think. At least this will go to the next row. Oh, right, I forgot. The most important thing is to say, and now call the function again. And remember, every time you call a recursive function, you should probably at least be just double checking to yourself, have I actually updated at least one of these parameters? Because if the answer is no, you're probably missing something. But if I look and say, oh yeah, actually I updated both of them. Row got updated and even temp got updated. So for sure this is moving me along in the process. Okay, so that's case 2. And then of course the more obvious case is, what do I want to do if I'm on a number? Well, of course I want to print the number. So that's temps num as usual. If I want to be a cool kid and print the arrow, I could certainly do that. So print temps num, print an arrow maybe after it. If I want to get fancy with this, I could arrange to have the null appear at the end, I guess, but for now maybe let's just leave that. So print the number. And now a typical mistake that we make is we say, and now keep going. So so call the function again. And that's true, I do want to do that, but just remind yourself, have I updated temp or row? No. So I should probably say, oh, you know what, I forgot. I'm supposed to toggle temp to the next box, right? So now when I call this again, I am at least sending it something different, right? If you want the null to appear, I would actually add that up here, wouldn't I? So I don't know, this is more of a style thing, but if you like it when there's a null, at the end, you could add it here, because of course if I'm on a null, that's probably when I want to print null, right? All right, I guess I could add one up here too. Huh? Okay, now we're really just getting into the, oops. Okay, so print a null if I'm on the last null so that I see that word, and then print our little message maybe on the next line. Okay, so let's see if this works, because we never know. So let's try to run this, see what we get. Okay, so let's see, where am I? Okay, so I called this hash.cpp. And shocker of shockers, I have an error. We don't like table. Oh, okay. I'll claim I did this on purpose, but I didn't. Right. So if we look at this error, look at this error, it's saying, oh, in the print function, table is not declared. Well, duh. Of course it isn't. That's correct, because of course, remember, if this is a function, I have to send it stuff. Now you're not going to have to worry about this in your program because you're doing a class. And remember, one of the nice things about a class is that a class automatically has access to all of the elements of or members of a class. But this is just a regular old function, so I better send it the table, right? Because I'm going to use the table. I apparently need to send it, and this is a little bit of a pain because I got to fill that in everywhere now. So everywhere I call the function, I got to add the third piece, and including in the main. Oh, we didn't do the main yet, so fine. Oh, right, that was another mistake, is that I forgot to actually call the function. So we load up our, maybe I'll print it every time, so that way we can check in. So let me call the this print function that we just wrote. And let's see, I'm supposed to send it, oh right, so of course I'm supposed to send it 3 things. So I guess there's sometimes a little bit of a question of, oh gee, well, when the main calls this, what am I supposed to send it? So temp, of course, remember, temp is where am I right now, row is what row am I in right now, and the last thing is just the whole table. So that's not a mystery. So the third parameter is going to be just the whole table. But how about for the first 2 things? So remember, I'm supposed to say, oh, where are you right now? And I'm supposed to also say, what row are you in right now? Well, when we call this from the main, hopefully it makes sense to say, well, what row am I in right now? I probably want to start at row 0, right? That would say, right, that makes sense to start at the top. And where am I in that row? Well, I'm at I probably want to start at the beginning. So temp should be pointing to where am I in the table? Well, I don't know. I probably want to start at the beginning of row 0, which, for one more time, is table. Now, I'm not going to write table row because I want to start on the first row, which is row 0. So I think if I do that, sorry, my commas are weird. So if I send it table bracket 0, that is the first pointer in the first row. That's a good place to start printing. I'm in row 0, so I'm going to send it the number 0, and I'm going to always send it the whole table. All right, so let's see if we've both fixed our error and also actually called our function, and I'm still terrible person. Oh, okay, sorry. So table is, of course, table's an array, right? Table is a whole array, and I forgot to put the brackets up here. So here we go, sorry. So table, array. There we go. Okay, so brackets, of course, tells us that it's an array. All right, third time's hopefully the charm here. Okay, this is, I probably have a semicolon issue. Line 69. Okay, does always help to have a semicolon at the end. Fourth time, maybe, please. Yay, all right. So let's try to run this and see if it actually works. So we're going to ask for a new number to be inserted. And remember, we're modding by 10. So whatever number I insert should go in the ones digit. So 26, for example, should go in slot 6. Okay, so that looks pretty good, I think. I can sort of count down, I think that looks like 26. I think that's slot 6. And of course, null, 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 null everywhere else, right? Because I haven't inserted anything into any of those. So that's pretty good. Do I have more numbers? Sure. Maybe 33. Okay, I think 33 ended up in slot 3. That's good. 199. Okay, that ends up in slot 9 down there at the bottom. So we should double check, does this work if you have a collision? So a collision now meaning I'm going to try to insert something into a row that already has something. So how about if I try 73? Oh, that's a 4. 73, that should end up in row 3 before the 33, which I think it did. Just to make sure that wasn't a fluke, maybe 53. Okay, so that ended up before the 73. All right, so I'm pretty happy. I think it seems to work. So I think we can call that a success. So that's pretty good. If you, like I said, I think in the printing function I give you in the starter code for the program, number 1, I didn't do it recursively, and number 2, I think I was cute, and I put row numbers in too, which you could do here if you really were dying to, but it's fine. All right, so that's 2 out of 3 operations done, and the last one is not hard. So here's our printing function that we mostly worked on last time and did a little sprucing up today. So searching is probably also something we might want to do, where, I'm going to let the user enter a number and decide and try to find it, right? So maybe I'll make a variable here to hold some number that we're trying to find. Find number? I don't know, right? Whatever we want to call that. And I'll ask the user to tell me what do you want to find. Let me grab that. Okay, so I'm in search of find num. Right. Okay, so, let me just grab our terminal for a sec while we still had a nice one. Okay. Oh, I can't get back up there. Yes, I can. Okay. So, right, so maybe we're looking at a table like this, and the user just said, I want you to find the number 73. Aha. So obviously we want at the end of the day to be able to print a yes, you found it, no, you didn't find it kind of message. Okay. So as a human, I look at this and say, how would I know if they say 73 right now? What's the best way for me to get the answer to yes, no? Well, obviously the answer is yes in this case because we can see the 73. But I think if we think about it, 73, if they say whatever number they say, I will automatically know which row I'm supposed to go to, right? So when they say 73, I mod by 10, and I get 3. So at the very least, I can cut my searching down to just scrolling through the list at slot 3, or in row 3 there. And then obviously, just as we've done this a million times, if I find it, I'll say, I can stop and say, yes, it's here. If I get to the end and it's not there, I know it's not there, right? If they searched for 93, if they said, I want you to find 93, I don't need to search through this whole through the whole chart. If 93 was in this chart, it would have to be in row 3. So if I get to null and I say, well, I didn't stop before this, well, it must mean then that I've reached the end of the list, which means it's not there, right? Okay, so first things first, this is the step that sometimes we forget, but first things first, I do need to identify what row am I going to do my business with, right? What row do I want to talk to? So I will probably find myself creating a variable to hold row. You may want to include this in your class because it's a nice variable to, just like temp. Sometimes it's nice to include a temp in your class just so that you can use it whenever you want it. You might want to do one for row. It's just sort of a helper variable, but not a bad idea. So let me do that. So it's a very easy thing. So the row I want to work with comes from the hash function. So that's hashing. And I want to send it, what value do I want to hash? Well, the user just entered this find num. So I want to go to that row. go to the row that this user's number might be in. So that doesn't actually go to the row, but that at least computes what the row number. Now if I want to scroll through that row, well, if I just said the magic word scroll, well, we know scroll means I probably need a temp to help me do my scrolling. But now the good thing I can say is, now if this was a regular linked list, I would probably have said node start temp, and then I would have said temp equals first, because we start at the beginning of the list. Well, remember, I don't have a first anymore, but I'd have lots of firsts. And remember, those are all known as table row. So table row is the first pointer in row. So temp is now pointing to the beginning of the desired row. And now I can pretty much do code that we've already done a bunch of times, which is to say, keep going while you're not at the end. And I want to just simply look, is this the magic number or not? Right? So I could ask, well, if temp's num is this find num, the one I'm looking for, then here's probably where I want to say something. Your number is in the list. Okay, and then I'm probably done here, right? I mean, well, it doesn't say I have to find how many times, right? So of course, I think a lot of you are using returns to say stop my function. And that's fine. So I can do a little return 0, and that'll at least cut this function off, and it'll say go back to the main now, right? This function's done. If you want to handle this more glamorously, you could have a Boolean that says did I find it yet kind of thing if you want to do that, but sometimes that's actually the easiest way to say I know if I get inside this if statement that rookie mistake. 2 equal signs, right? If I find the number, then I'll print my little message and I'll get the heck out of there. So how will I know if I didn't find it? Well, if I get to the end of the while loop, or if I get to the end of the list, then of course the while loop's going to turn off when temp is null. So if I get to null, that means I'm going to jump out of the loop and I'll be here. Well, if I didn't break out earlier because I found it, must mean that it's not there. So if I end up surviving, then it must be the case that the number is not in the list. Okay, so this is a cute way. You don't have to do it exactly this way, but I think that'll do the trick if all I'm looking for is a yes, no. If this was a Boolean function, I could return true or false instead of doing my printing right here, and then let the main do the printing. But, well, anyway, this is the way I guess we're doing it, so be it. Now, I'm about to do the same mistake I just made a second ago. I didn't fill in parameters for this function yet, so I should probably just take a quick look through here and say, well, what did I need in this function? Now I made a couple of variables, so those are local variables, so those I don't need. I made them, but it looks like I'm using the table for sure. But I think that's about it. I don't think I'm using anybody else. The hashing is a function, so functions can talk to other functions. No funny business there. So I think maybe I just need the entire table. So node star table, and then I'll remind myself that's an array. So I might be able to get by with just that, unless I'm missing something. So let's come back down to the main. Now, when do I want to search for something? I guess I could search every time, I suppose, but well, I might probably more so want to do it at the end. Well, just maybe I'll put it here anyway. So I'll print the table, and then I'll call our search function so that I can each time, it's probably excessive, but that's all right. Each time I can do a query to see, hey, is somebody in the table, and then keep going. All right, so let's try this. I didn't add much, so hopefully I didn't mess this up too badly. And if this works, then we're all set. So, all right. Oops, I didn't mean to run the program again. All right, so let me compile. And I'm a terrible human being. we don't like the return. Oh, all right. Maybe is it just return? It's being a little too casual here. Oh, just return maybe, I think, because it's a void function. Let's try that. Okay, we're happy now, sorry. So if you want to jump out of a void function, so this is a void function, right? Yes. Just return instead of return 0. If you have a return that you're making, then you should fill a 0 in. Okay. So let me run this. So I'm going to insert a number, 33 again, I guess. So I got 33 in the table. All right. Is this weird? There we go. Okay, this is a little excessive, but we'll search for a number. Maybe let's pick one that's not there. 55, whatever. Hopefully it says no. Okay, that's good. So 55 is not in the list. Great. So let's build up the list a little more before we go too crazy here with searching. So I'll insert 67. And looks like 67 went in the right place. So maybe let's search for one that is here. So like 33, for example. And it says it is in the list, so that's good news. Do a few more here, maybe 27. So 27's now inserted in the row with 67. So of course we should always test, right? This is what I do when I run your programs, and sometimes I'm like, oh, this works most of the time except in these sorts of cases. So I should double check, will it find the first number in a row? Will it find the last number, right? So maybe 67, for example. Will it be able to find that? It's not the first number. I mean, hopefully, yes. Oh, well, this is well-timed because I've crashed. And I think I know why, and probably some of you were screaming at the screen as you were watching me do this. What do we always forget, or I should say, what do I always forget, and you all sometimes forget to do, is that, of course, when I'm doing a scroll, a scrolling loop, well, it's not much of a scrolling loop unless I scroll. Okay, so I think I forgot to actually say go to the next one. Which is good. I'll pretend I did that on purpose, but it was accidental. But right, this is why you sort of have to test, right? Test your program with more than just, cool, it works, let me submit this. Not that anybody does that, I'm sure. But okay, so let's try that again and see if I have better luck. So let's go with the 45 and search for 45, great. And sure, and 33. And maybe I'll look for something that's not there, 88. Sure, more numbers. And 15. Okay, so here's where I got fouled up a second ago, so let me try to find 45. Hopefully I fixed my mistake. Oh, good, right, and it says 45's in the list. Let me throw one more number in here, 65. Okay, so now I have this big list here with 65 in it. Now, I should probably, again, just to try to identify all the things that might go wrong, I should maybe look for a number that's in a list that has stuff, but not the number I want. So maybe I could look for 55. 55 is going to look in row 5. But of course, hopefully it gets to the end here and says, no, it's not here. Good, right, which it did. Okay, so I think I'm pretty satisfied that this code works. Maybe run it a few more times in some other weirder scenarios if you want. So I think it's pretty good. So we've got a decent hash program off the ground. Like I said maybe a few times, I'll save, this exact program I'll save and post with this video that you're watching right now. So if you want to grab this, you can. I took this program or something like this and just sort of tweaked it a little bit and left that for you as the starting code for the one you're going to work on for next week, which is a hashing class, a class that implements a hash function, a hash table. So there's a little more to it because, number one, it's a class, so you got to sort of follow the class rules. And then I added a few other features, mostly with the searching. And the one that's going to take you the most time, though, is the deleting or the removing. So in addition to being able to add, you also want to be able to remove. And as usual, that's always a little bit of a pain because you got to do some cases and, do I want to delete is the first thing in the list? I give you some advice on the assignment sheet, but Anyway, so good luck with coding. Try to put some decent time into it over the weekend. There's no readings or anything else, and this is mostly it. I do have one more day of notes, so we'll come back to notes for Monday's class, and I'll go through that stuff. I think I have Wednesday as the due date for the program, the hashing program. So hopefully a week is a decent amount of time to work on that. And we will have a quiz next week. Right now I have it down for Wednesday. We'll sort of see maybe how the rest of this week goes. But it'll be on all the stuff that we've done since the midterm. But anyway, well, more details about that later. So good luck with the program. As usual, if you have questions, please feel free to reach out, either via email or if you want to Zoom chat. I'm happy to chat with you and help you with whatever you might need help with.